We present our paper for exploring the combination of spatially-aware tablets with augmented reality head-mounted displays for immersive analytics with our stream prototype. This work was done at the University of Konstanz by me, Sebastian Hubenschmidt, and my co-authors Johannes Zagermann, Simon Butcher, and Harald Reiterer. Our stream prototype aims to facilitate the interaction for immersive analytics applications with a multimodal interaction approach. We combine different input and output modalities with our hybrid user interface using a head-mounted display and a spatially-aware tablet. To first test our prototype design, we've chosen an established 3D parallel coordinates visualization that consists of linked 2D scatter plots. Each scatter plot can be placed in a 3D space, and users can specify 2D areas on each scatter plot that can filter out data from connected scatter plots. Stream improves upon interaction in AR by using a hybrid user interface consisting of an AR HMD and a spatially-aware tablet. In addition to the HMD's existing input modalities, such as head gaze and speech input, we can additionally employ the tablet's touch input and spatially awareness as a tangible input, thereby avoiding tiring and possibly imprecise mid-air gestures. However, this also means that users need to switch their attention between the two different output modalities. Our stream prototype bridges this gap with a novel eyes-free interaction technique and a tablet lens interaction concept. First, for general interaction, we created a novel eyes-free interaction menu that allows the user to interact with a selected visualization. Users see the available menu actions on an AR head-up display, as you can see on the bottom right, and can then press the corresponding corner of the tablet to perform this action without having to look at the tablet. A set of buttons in the middle of the tablet have a higher interaction cost as they require a display switch and are thus reserved for more severe actions, such as deleting an object. In addition, users can enable voice commands by touching the tablet with both thumbs. When the voice input is listening, the AR head-up display extends and shows all available voice commands. When placing a scatter plot, users can use head gaze for the general position, the tablet's physical position for rotation, and a swipe gesture to control the distance of the scatter plot. In addition, scatter plots automatically snap to other nearby scatter plots, as can be seen by the alignment lines. This removes any height differences and facilitates the comparison of data between different scatter plots. The large tablet display allows for familiar touch interaction to directly manipulate the scatter plot's data. For example, users can easily search for dimensions in a list on the tablet and draw filters directly in a scatter plot on the tablet. The changes are instantly synchronized with the AR visualization, allowing users to observe the filter effects directly. These filters can also specify the line color across all connected scatter plots, which helps to, for example, track clusters across different scatter plots. Aside from our eyes-free interaction menu, Stream also alleviates the necessary attention switch between the AR visualization and the tablet through our novel tablet lens interaction concept. Instead of looking down at the tablet for interacting with the 2D visualization and thereby losing critical context from the 3D visualization, users can simply lift the tablet in front of themselves to activate this lens mode. The tablet will automatically switch from the eyes-free interaction menu to the 2D visualization view, while the selected AR visualization will rotate towards the user and roughly match the tablet's position. This 2D view also works for displaying the links as 2D parallel coordinates visualization on the tablet, which completely eliminates any possible errors from the 3D perspective. Using this stream prototype, we validated our interaction concepts in a user study with 8 non-experts, which allowed us to shift our evaluation focus towards our interaction concepts. During the study, we also observed participants through an AR tablet, which inhabited the same AR space as our participants, allowing for a live observation of the study. Based on our findings and experience, we extracted design insights and research implications for the use of spatially-aware tablets, multimodal interaction in AR, and a general system usability in hybrid user interfaces. With our work, we hope to inspire more research into the use of hybrid user interfaces in augmented reality for interacting with data visualizations. For more details on our work, please refer to our paper. You can also find Stream as an open source project on GitHub. Thanks for listening.